then let's start. So yes, my name is Lars. I'm part of the challenge organizing team for the VAND 4.0 challenge. VAND is short for Visual Anomaly and Novelty Detection. And as Jimmy just said, there's also a corresponding workshop at this year's CVPR. And it's the fourth in a row of these workshops and challenges, so it's quite an established format. And today I will give you, in the next 10 minutes, some insights into this year's challenge design. But first of all, to get everybody on board, I would like to answer the question, what is anomaly detection in our understanding? So to us, anomaly detection is the task of detecting and localizing defects for quality control. So given this example of pills, we can see that some pills are defect-free, some pills contain a defect. These ones are highlighted in the orange boxes. So there might be some cracks, there might be some dents, there might be some color where there should not be color. So the task of our anomaly detection system is to detect these defects, plus also to localize these defects. To be more precise, this means that what we expect from our anomaly detection system is to output an anomaly map. It's like a heat map that tells us where the defect is, and it also helps us to decide if there is a defect on the test image, such as this crack here. Vice versa, if there is no defect on the anomaly, there is no defect on the test sample, we would like that our anomaly detection system responds like this, so actually showing no highlights in the anomaly map. Okay, so anomaly detection is about detecting and localizing defects for quality control, but why do a challenge? Well, we saw that the performance on existing datasets and benchmark slowly but steadily saturates. For example, what you can see here on the left-hand side is a table from our recent paper where we compared the performance of different methods on established benchmarks in anomaly detection, such as AMITech anomaly detection dataset or the visual anomaly detection dataset. And you can see that the performance nearly reaches 100%. And it's hard to differentiate between like true meaningful innovations and just some small configuration changes in the model design. And so to foster research in the domain of industrial anomaly detection, we were not the only ones to release a new dataset. So we released the AMITech 82 dataset last year, but there were also others that observed the same phenomenon. For example, the authors of the Kaput dataset, they also noted that existing benchmarks have reached saturation. So there's definitely time for new benchmarks and new challenges. And in these new benchmarks and challenges, we consider important practical issues that have been overlooked before. So there are two domains here we cover with this year's challenge. On the one hand, we cover the industrial manufacturing domain, and on the other hand, we cover the retail logistics domain. So if you're more interested in the retail logistics domain, I would like to point out that there will also be a lightning talk on March the 19th in another Voxel 51 meetup. So please feel free to join there to get to know more about the track that will cover the retail logistics anomaly detection setting. But today I will talk about the industrial manufacturing setting, namely the AMITech 82 dataset, which will be the basis for this industrial track. So let's dive right into it. So this year we will have two tracks, and in the next 2 minutes you will get some insights into the industrial track, which is based on the new AMITech 82 dataset. I just dive right into it and tell you about the open challenges we saw in industrial anomaly detection, which would be to handle product classes with high intraclass variability. This means that every sample might look different, and so it's hard to tell if this is an anomaly or if this is just a new configuration. Another important topic we see that can be improved on is the localization quality. So in the industrial settings, it's not only important, as mentioned in the beginning, to know if there is a defect, but also where the defect occurs. For example, you would like to do some post-processing to determine the severity of the defect. Third, we would also like to improve the threshold estimation. And this is a problem that is really often overlooked in science, because usually evaluation metrics are used that do not require to decide for a specific threshold, but that rather integrate over all possible thresholds. So this problem is until now kind of circumvented. Fourth, anomaly detection faces the challenge that sometimes the environmental conditions such as lighting change, and this poses also a challenge to anomaly detection algorithms, because sometimes it's hard to say if this is just a change in the environmental conditions or if this is actually a defect. So we would like our models to be robust against these changing environments to a certain extent. And last but not least, we would like to see more efforts and more progress in reducing runtime and memory requirements of industrial anomaly detection algorithms, because usually what you have in industrial settings is not a GPU, but only an edge device. So I think I can go into some details for two of these points that are also that align most with this year's challenge goals. So for example, the first one would be to improve the robustness against changing lighting conditions. And as you can see, this is an example, or are three examples from our new dataset, the MBTech 82 dataset. And you see that we captured each scene under at least 4 different lighting conditions. In this case, we captured a while under 6 different lighting conditions. We have the regular setting. This is also the setting we see during training. But during testing, we might see that there is a slight underexposure or exposure of the images, or that there are some additional light sources disturbing the natural appearance of the regular lighting setting. And the same goes for the other two examples here, like wall plugs and rise. We can see that sometimes some shadows might occur, and for the rise, the color temperature might change depending on the lighting setting. So we would like to that our anomaly detection system is robust against these kind of changes, and this is definitely challenging and not solved yet. The second point I would like to highlight here, or the second challenge, is the reduction of runtime and memory requirements. So as mentioned before, usually we do not have a high-power GPU in the industrial setting, but rather an edge device. So it's runtime and memory footprint are really important criteria whether or not a model can be deployed in practice in a practical application. Of course, this depends on the specific use case, but in general, the high production rates really demand fast algorithms and lightweight algorithms. And what is more, in this new data set, we also cover small defect sizes so relative to the image size, small defect sizes, because if you have a small defect in a large image, you need to look at the whole image, but still need to detect this tiny defect in time, so in real time sometimes. Okay, so I'm nearly done with the lightning talk. So what you would like to know now is maybe how to participate in the challenge. So for this, I would like to show you the website. Let me just share the right screen again. We go. So if you're more interested in the challenge, please feel free to check out the website. I posted the link in the presentation. I will also post it in the chat right after this talk. So as you can see, here you will find all the information. You can subscribe for updates and stay updated. And you will get a summary of the challenge objectives and categories. And also, of course, the important dates. And I think for now, the most important date is March 25th, where we will release the detailed track descriptions. So if you're interested in taking part in the challenge or know somebody who might be interested, please stay tuned. You will find more and more information to come. Big shout out also to my challenge, to the other challenge organizers, and also to the challenge sponsors. Yeah,